rectangle approximation method. And if you use left-hand endpoints of your interval, that we call left RAM or LRAM. And then if we use the right-handed endpoints, then it's RRAM. And these pictures are in your book. You don't really have to draw them all if you don't want to, but I just want to kind of show you the difference here between them all. Some lovely pictures there. I believe this picture's in your book. I might be wrong, but let me tell you in case you want to write down where it is. Yeah, it's on page 265, this picture is, if you want to kind of... but really what we're seeing here is the first picture is using the left endpoints as the height of the rectangle. And what do I mean by the left endpoints? I mean for each rectangle, the height, like on this one, the height is the left endpoint. Like notice there is no height. For the second rectangle, the height is the left-handed endpoint. That would be the left endpoint of that rectangle, the left endpoint, the left endpoint, the left endpoint. Notice when you're doing the left-handed endpoints, the last one's never used, right? Like this endpoint is never used because you only are using the left side. This one's the one that we did yesterday. We used midpoints because midpoints, notice on this one, what's going to happen when we figure this out? Is it going to be really over the actual amount, under the actual amount, or maybe pretty close to the middle? With all those rectangles, if I did the area of each one of those rectangles, how close is that going to be to the actual area underneath that curve? Is it underestimating, overestimating, or exactly right? It's underestimating, because you notice all these rectangles are underneath the curve. You see that? Yes. And so left-handed endpoints on this one, not, you're going to definitely know that that's an underestimate. Why did I pick midpoints to start with yesterday? Because it seems like midpoints are kind of nice, because notice when you do the midpoint of each rectangle, like we did yesterday, what's kind of nice about it is part of the rectangle is over the curve and part of the rectangle is under the curve. It's still not going to give you the exact amount, but it's going to be better than that. Do you agree with that? That's midpoint. And then this is the example of if we use right-handed endpoints. Notice it's the exact same rectangles, only now I'm using the right-handed endpoints. So again, just like on the left-handed ones, one endpoint's not going to be used. You're not going to ever use that first endpoint because you're using the right side of each rectangle, and this would be right. Eventually, we're going to call these Riemann sums, named after this awesome guy named Riemann. But right now, your book's just calling it RAM, so we're just going to stick with that. Okay, but it's rectangular approximation method. So today, here's the really fun part. We're going to do one problem, but we're going to do it with left, midpoint, and right, and see what our approximations are. Are they close to each other, and which ones are underestimating, which ones are overestimating? I don't know. We'll see. Depends on how far we get. Then we have the programming stuff. So, I've never done the programming stuff all together in one day because I've never figured out how to link the Cilio calculators together. But I learned in my summer workshop. I think it will save the program even if your batteries run out, because there should be like a backup battery in there that would save your program. But if not, here's the great thing: we now know how to link them together. So if for some reason you lost your program, we don't have to rewrite it every time. And again, they're going to tell you how many rectangles or how many intervals to make, because if you make a different amount of intervals, your answers are going to be different. And so they're when you're doing these. And so again, the directions are we're going to find the approximate distance traveled, or the approximate area under that curve, but we're going to use all three, the left-handed endpoints, the midpoint, and the right-handed endpoints. And I just picked a nice easy one here. We're going to use x squared. We're going to go from x equals 0 to x equals 3. And we're going to use 6 subintervals, which means you should have 6 rectangles when you're done with this. Okay. Stay with me. Are we going to do it all? Okay. So again, going from 0 to 3, I'm going to make this kind of spaced out because I want to be able to draw on my rectangles. Y-axis, think about what the biggest y value you're going to need. If x is going to 3, what's the biggest y value I'm going to need? 9, because it's x squared, so you can go by ones, whatever you want to do. I'm going to just go by ones because I feel like 9's not that big. And you should be able to sketch a pretty good graph here. At 0, it would be at 0. At 1, it would be at 1. At 2, it would be at 4. And at 3, it would be up here to 9. And again, I'm going to say I'm stopping at 3, so I'm going to go ahead and draw that line in there. Remember yesterday I gave you that formula for finding the area using the midpoint, and I told you like we just take the width of the interval because it's width times length, and then the length of that rectangle or the height of that rectangle always has to do with where it crosses. Same thing today, only we have 3 different places we're looking at. We're going to use the left endpoints, then we're going to go back to the midpoints, and then we're going to use the right endpoints. But it's really still the same idea. So if I start here with the left one, or maybe we should make our rectangles first, or at least our intervals. 6 subintervals. Right now, if I just drew a line at each one of these, you agree that that would be 3. So if I just cut each one of those in half. So I'm not going to actually draw that rectangle yet because I want you to, I'm going to do it with the each different color here. But you could count there. We would have 1, 2, 3, 4, 5, 6 rectangles, or 6 intervals. Remember that area is length times width of a rectangle. I'm going to change that length to height because I really think about, I don't know, I just like it better. So I'm going to say width times height. Are our widths all the same? Yeah, we broke those into nice 6 little equal things. Eventually, when we get closer to the test, we're going to talk about some, a lot of times on the AP test, they don't give you equal intervals, and you have to do each one separately. But right now, ours are all nice and equal. So what would the width of each one of these be? Half? The height of each one of those, if I'm using the left endpoints, and I'm going to change color here so you can see this on my graph. If I'm using the left endpoints of each interval, do you agree of the first interval from 0 to 1/2, the left endpoint would be 0? That means that's the height of the first rectangle. That's not a very good rectangle. What about the next rectangle? From 1/2 to 1, if I'm using the left endpoint, do you agree that that's 1/2? And at 1/2, would that be right there? And I get a nice little rectangle like this. And if I keep going and I keep using the left side of each little interval, this left side would be at 1. So where does that cross on the graph? Up here. And I would get a nice little rectangle like this. From 3/2 to 2, I would use the 3/2, but that height would be up here. And it looks very much like the one that we just did on the previous page here, where they're all just nice underneath. I'd use 2.5 would be right here. And those would be my 6 rectangles that I'm using. So the big thing is you just got to make sure you're using the right point for your height. If you're using the left ram, you're going to use F of the left endpoint every time. Just like on the midpoint one yesterday, we used the midpoint every time. And you have to plug it into the function because you're actually trying to find the height of the function there. So that's where it's coming from. And again, the picture's great, but once you get this, you don't even have to have the picture to go with it. Like, you just have to know what values you're plugging in. So if you know your intervals, it doesn't matter how high it is, you can just use the function to do that. And again, I'm going to show a good amount of work here. For the first one, my first rectangle, what is my left endpoint? 0, so I'm going to do F of 0. And I'm just really going to go in a row here. You agree that it's going to be 0, and then the next one's going to be 1/2, and then 1, and I'm just going to keep going until I get my 6 rectangles. You follow me on that, like we did yesterday? Oh, this 5/2. So I have 1/2 times F of 1/2. That would be the area of my second rectangle. Plus 1/2 times F of 1. Totally going to run out of room. Plus 1/2 times F of 3/2. Plus, I'm going to come down here, 1/2 times F of 2 plus 1/2 times F of 5/2. Couple things I want you to notice about this. One is when you're using the left endpoints, you don't actually use the end points, the right endpoint, because you run out of it. A lot of people just remember that. Oh, I start with the leftmost point and I go all the way up and don't use the last one. You should only have 6 rectangles, so it should make sense that if you start with 0, 1 rectangle, 2 rectangles, 3, 4, 5, 6. We're not making another rectangle over here, right? It stopped at 3. So also make sure you have the right number of problems there. And then we're just going to plug it in. Just like yesterday, since they all have a 1/2 in it, if I wanted to, could I pull that 1/2 out and do that at the end? You don't have to, but since they all have a 1/2 in them, since all the widths are the same, that works out really nice. And now I'm just going to plug in each of those points into my formula up here. So I'm going to get 0 squared, which is 0, plus 1/2 squared, which is 1/4, plus 1. 3/2 squared is 9/4, plus 2 squared is 4, plus 25/4. On the AP test, on the free response part, sometimes they give you a question like this, where you have to use rectangles to approximate something. On the no calculator part of the test, remember that you don't have to simplify your answers, which means on a free response, if you were trying to work this out and you had no calculator, they don't want you to miss the problem because you messed up your math. You could leave your answer like that. So something to think about. We don't usually leave our answers like that. It's kind of a whole new world of saying, oh, I don't have to work that out. But if you don't have a calculator, you would just leave it like this. We have calculators right now, so we would work this out. And you could add that all up, right? But I'm just kind of throwing that in there. So who added this up yet? Anyone? Is that including the 1/2? Again, use your graphing calculator if you haven't been using it. It does give you a decimal, but again, a reminder, if you would just hit math and number 1 says arrow fraction and you hit enter, it'll change that to an improper fraction every time. I got 55/4. Did you get 55/4? That's 1/2 times 55/4, which would just be 55/8. And just because I want to kind of compare our answers, and this actually is a terminating decimal, I think that is 6.875, just because I want to kind of show you how these are all close to each other, but they're actually different values. This would be our left-handed approximation. On a test, if I say show me the work on a quiz, if I say show me the work, I expect to see some work here. If you jump straight to this step and you don't show me this step, I'm okay with that. In your notes, I like to have this for you so you can go back and see where it came from. But I need to see this at least, especially because I'm going to show you a way to do this on your calculator today. So if I say show me the work, then I expect to see this, not just an answer, because I'm going to show you how your calculator can use a program to do this. We're only 1/3 of the way done, right? So let's do the midpoint one next. That's what we did yesterday. What you should have done yesterday. We still have 6 subintervals. We're still dealing with x squared, and we're still going from 0 to 3. We can make this whole graph again, right? Every time we can. But you also, I don't know if on number 4 on your homework last night, if you redrew the whole picture again, you don't really need the whole picture. I'll draw it, but I want to show you how you could kind of do it without it. You really just need that x-axis from 0 to 3. And I'll make the y-axis in a minute because if you want to have it in your notes. But I'm still going to have the same subintervals here, so I'm going to break each one of these in half. But now, if I'm using the midpoint of each one of those intervals, could I find the midpoint without actually looking at the entire graph? Like for my first interval, from 0 to 1/2, do I know where that midpoint is? Right here in the middle, right? Which would be at 1/4. And if I had my curve here, I can draw it up here. Here's my curve. We're just going to kind of make it very rough here. Then that first one would be at 1/4. That would be my first rectangle. And notice, part of it's above the curve, part of it's below the curve. But you don't have to do that because all you need is the what value to plug into the function. Between 1/2 and 1, what is my midpoint going to be that I'm going to plug in? 3/4. And again, if you wanted to draw the picture up here, at 3/4, go up to your curve and draw that lovely little rectangle. If you're struggling here, notice that every one that you're skipping is also a 4, right? Like this was 1/4. This is 2/4 or 1/2. 3/4. This would be 4/4. So if you're struggling with your fractions here, that hopefully makes sense that the next one's going to be 5/4. And the one you'd skip would be 6/4 because that's 1/2. And then 7/4. 8/4 would be 2. Then this would be 9/4, 10/4, and 11/4. Every time, it's a rectangle, so it's length times height. Sorry, width times height. Oh, I changed the. Our width is still 1/2, but now our height is going to be f of the midpoint. All that's changing every time is what you're using as the height of your rectangle. Do you see how you don't need a picture to do this? Like you just maybe need a line. You don't have to draw all the rectangles. It's nice, it's cute when you draw the rectangles, but it's really unnecessary. But I'm not gonna draw all these in. And so I can say that I know this is gonna equal 1/2 times f of 1/4 plus 1/2 times f of 3/4, and I'm just going to go through for all 6 of those rectangles. It'd be nice if they only made us do 3, right? Or 2. Plus 1/2 times f of 5/4 plus 1/2 times f of 7/4 plus 1/2 times f of 9/4 plus 1/2 times f of 11/4. Not a bad idea to make sure you have 6 different areas that you're finding there, because you have 6 rectangles, so it's a nice little check to make sure you didn't leave something out. Just like the last one, we can factor out the 1/2, and we're just plugging it in. Follow me on what I'm doing here? It kind of gets a little repetitive after a while. So again, this next step is the step that I really want to see of you plugging it in. And if I plug that into x squared, I'm just going to square each one of these. So I would get, 1/16 plus, I factor out the 1/2, 9/16 plus 25/16. Oh man, look at this one. They're all 16ths. Plus 49/16 plus 81/16 plus 121/16. When I added all that up, I got 143/8, which would be 143/16. Is that right? Did you get that? Which is 8.9375. What was our left ram? Does it make sense that this one is bigger than the left-handed one? The left-handed one, all those rectangles were underneath the curve, yes? This one, some are over, some are above. Some are over, some are under. So, before we do the right-handed one, what do you think is going to happen when we get the right-handed one? You think it's going to be bigger than that or smaller than that? Because on the right-handed endpoint, every rectangle is going to be above the curve, so it should be bigger. So do the right-handed ones. Let me draw your line here. My 0 to 3 keeps getting bigger. Still going to have my rectangles broken up like this. What's the difference on the right-handed one? If you're going to use the right-handed endpoints, what's going to be your endpoint for your first rectangle? 1/2. So you're not going to use 0 up here, right? You're going to not use 0. You're going to use 1/2 and 1 and 3/2 and 2 and 5/2 and 3, because you're using the right-handed endpoint each time to make your rectangles. If you want to write out the little formula like we did in the last one, it would be width times f of right endpoints. some people go back and use their left-handed ones that they already did, and maybe just add one more to it, because if you agree on the left-handed RAM, we use 1/2 and 1 and 3/2 and 2 and 5/2. And all we have to really do is add this to it, because that 0 is 0, so maybe you notice that. It's a great thing to do, but I'm just going to show it works here. Are we getting there or not there? What I got 94 or 91 fourths times 1/2. I got 91 eighths, or 11.375 as my answer. Our answers really weren't that close to each other, right? One was at 6, one was at 8 something, and one's at 11 something. What do you think would happen if we made 12 rectangles to the 6 rectangles? They'd be closer together. What if we made 100 rectangles? We made 1,000 rectangles. Want to do this with 1,000 rectangles? Yes.
So if you took the average of those three numbers, would it be more accurate?
Not necessarily. I mean, I guess we could look at it, but what we really want to do is think about making more and more rectangles, which is where our calculator comes into hand. Look on in your book on page 266, like the middle of the paper. They did this exact same problem, and they started with 6, and they kept increasing their number of rectangles. And look at that little chart in the middle. Notice at 6 rectangles, they got the same answers we did. And then they did 12 rectangles. They were a little bit closer. And then they did 24 rectangles. And then look, they ended with 1,000 rectangles. And those became pretty close to each other. Do you agree with that? Like, if you did 1,000 rectangles, you could say, I would say probably about 9 would be a good estimate there. But it would be hard to get that from just 6 rectangles. We're not going to do these problems by hand with 1,000 rectangles, but I want you to realize that the more rectangles we use, the better that we can get, which is why we have this program that we can put in our calculators called RAM. And normally I give you this lovely sheet of paper with 30-some steps to do it. But I have 2 calculators with this on here, and we're just going to play a little game here of transfer this program, and then the next person can transfer to someone else, and then we can go from there, right? So, there we go. It is like telephone. So, put this calculator to your calculator. And then I'm going to pass it to John, because then we'll have 4 calculators. Yes. We still have like 8 minutes. So now hit link, second link, and then you want to receive. And then we're going to hit second link, and you want to go to the program, and you want to select. So now you share with someone else. Go to the second link, and you want to receive on yours, and then we're going to go to the second link on mine, and we're going to send a program. So you're going to go to retrieve, and you need to select the RAM, transmit, done. Okay, now you go to someone else. Give Kate what it's like. Okay, do not do this because you're on. program and see if you have RAM on there already. It's P, it's just a button. So second link for C. And then second link program select. Who does not have it on there? Do you have it on yours? Do you have it on yours? We tried to label the calculators as calculus. That's quick. That's on the AP exam, I always tell people they say in the directions they are not going to clear your calculators. But on the part that you're allowed to use a calculator, there's really not. I mean, you can program stuff in there, but on the part that you're allowed to use a calculator on, programming a million is not going to help super much. But I always tell them if you want to take the time to put a million things on your calculator, you can. But most of the stuff that they're going to test you on formulas is going to be on your calculator. Here, you can get your calculator. Do you still need it? Yeah. Steven, do you have yours? Does everyone have it on their calculator now? Okay, so here's the idea. The last couple on your homework today is we can use this to do this on our calculator. Instead of doing it by hand, we can use RAM to estimate the area of the function 1 over x from 1 to 3 for the following values. So you might want to write this down. This is an example. Sorry. I don't know if this one's for you or not, but it has for. Do you have your own calculator? Belongs to you? Or is it mine? Okay, just making sure that I get the right one. So here's our kind of important steps here. You could kind of just write the function from 1 to 3 and then write LRAM, MRAM, RRAM, and these numbers. Like you really don't have to write a million words down here. But when you want to use this program, you got to hit the program button. And you should have RAM listed on there. If you have other stuff on there, that's okay. But you should have RAM. And you want to execute this program, which means run the program. So at the very top, you'll see execute or EXEC. That should be highlighted already. If RAM is your only program, it should also be highlighted, but if not, you need to highlight that RAM and hit enter. And when you do that, it goes back to your original screen and it says program RAM. Yes? Hit enter again. And it asks you, what is A? A is the endpoints from A to B. So enter A, and in this case, we're going to enter 1. So you just enter 1 and hit enter. And then it asks you B. B is the other endpoint. So in this case, we would put 3 and we would hit enter. And then it says number of subintervals, right? They want to know how many rectangles are you trying to make. And now that we have a program, we can just keep going from smaller numbers to bigger numbers. So let's just do 10. The more intervals you enter, the longer it takes your calculator to calculate it. But if you do the subintervals, in this case, I'll just put 10 for the first one. You hit enter again, and it should just think about it, and it should give you left equals, mid equals, right equals. Well, then that means something has gone wrong. Oh, you know what we forgot to do? Don't leave. Here's an important thing. We forgot to say what equation we're using.
Harris, Brogan
Don't you
Derringer,
the y equals
Lexington
part?
Hills, Kira Moreland, Tessa
Where you
Cox,
go to graph y
Alexis
equals.
Carter, the office please.
And we have to tell it what function that we're actually finding rectangles of. Sorry, I kind of forgot that. So you got to put y equals 1 over x.
For the graph part?
Yes.
And then how do you go back to calculate?
Hit second quit, and you got to redo it again though. Like you have to go back and hit program again and tell it because it was using. For those of you that got an answer, you had something graphed already. For those of you that didn't have an answer, I bet there was nothing on your y equals part. But you got to tell it what equation we're using. Sorry, I kind of forgot that.
Wait, will you hit program over?
Yes. So you have to hit program again. We'll talk about this tomorrow. It's really fast to do. We can do it tomorrow together. 5 and 6 you're doing by hand. I think 9 and 12 you're using the calculators for. So we'll talk about this more tomorrow, and I can help you with it. If it still says error, come and see me. All right, but you should at least be able to do some of that. Okay, so try the program out, see how it works. We'll do more tomorrow. Don't lose your calculator.